President of the United States.
Nearly 2 centuries ago, in this room, on this floor, Thomas Jefferson and a trusted aide spread out a magnificent map. The aide was Meriwether Lewis, and the map was the product of his courageous expedition across the American frontier all the way to the Pacific. Today, the world is joining us here in the East Room to behold a map of even greater significance. We are here to celebrate the completion of the first survey of the entire human genome. Without a doubt, this is the most important, most wondrous map ever produced by humankind.
The Human Genome Project is the ultimate fulfillment of the work that Gregor Mendel began. Its goal is to determine the complete sequence of the bases in all the human chromosomes and defining the location of all the genes in those chromosomes. In what may be the most unlikely birthplace of a science, the discipline of genetics took root in a humble garden in the courtyard of a monastery in the ancient Moravian city of Brno. Today, a weathered stone foundation is all that remains of the garden's hothouse, and only a grass yard and lone sycamore mark the spot where Gregor Mendel, an obscure Augustinian monk, bred pea plants nearly a century and a half ago to learn how traits are handed down from one generation to the next. What Mendel discovered from those pea plants revealed the fundamental laws of inheritance. On July 22, 1822, in this village called Hinchese in Silesia, then part of the Austro-Hungarian Empire, Anton Mendel and his wife Rosine recorded the birth of their first and only son, Johann. He was christened in this church 2 days later. They also had 2 girls. At the time of his son's birth, Anton Mendel farmed this small plot of land and grew fruit trees and had beehives. Growing up there, young Johann knew he was not destined to be a farmer. Looking toward a different future, he attended the village school. The teachers soon noticed that young Mendel was an intelligent boy, and in 1833 they arranged for him to attend a more advanced school in Lipnik, some 16 miles away. Mendel wrote of himself, "Owing to several successive disasters, his parents were completely unable to meet the expenses necessary to continue his studies, and it thereby happened that the respectfully undersigned, only 16 years old, was in the sad position of having to provide for himself entirely. For this reason he attended the district teachers' seminary in Opava. During his 6 years here, one of the subjects he studied was meteorology, in which Mendel had a lifelong interest. His father suffered a serious injury and asked him to take over the farm, but young Mendel still wanted to continue his education. His younger sister, Teresa, helped by offering him part of her dowry to continue his education. In 1841, he entered a 2-year term of study at the Philosophy Institute in Olomouc. He took a course in physics and began to appreciate the significance of a mathematical approach to the world in general and the studies of plants in particular. One of his teachers was a priest and friend of F.C. Knapp, the abbot at the Augustinian monastery at Brno in Moravia. He recommended Mendel as a young man of solid character, intelligence, and also conversant in Czech, the main language of the monastery. Mendel entered the monastery of St. Thomas as a novice at the age of 21 on September 7, 1843.
He was frustrated by poverty and was eager to go in his education, and he came as a talented pupil of physics. The Augustinians were in those days a teaching order. They supplied professors for monarchs' universities, lycea and gymnasia, and Mendel had the best opportunity to go on with his education, not only in theology, but also in physics and natural history.
As was the custom, Johann Mendel adopted a new name, Gregor, the name by which we now know him. The monastery was founded in the 14th century, and its fame spread partly because of its possession of the Black Madonna, an image of the Virgin Mary. It is believed by some to have supernatural powers, and is said to have been painted by the Apostle Luke. By far the most important asset of the monastery was its library.
There's a story that Mendel's buddies, you know, the other monks in the monastery, used to call out to him from the library windows and you know, just make fun of him for what he was doing. And it made sense because right under those library windows is this little narrow strip of land that is known as Mendel's garden. But if you go to the library in Brno, as I did, you find out that there's a secret to this library. The main part, the big formal part, is very ornate, very beautiful. It's got, you know, carving on all the bookcases and gilt everywhere and parquet floors and paintings in the ceiling. And all the books are leather bound and beautiful. But there's a secret in the library. And the person who took me around to show me this went over to one corner of the these walls of bookcases, and this bookcase was half empty. And it's half empty because it's really a door. When you go through the secret passageway, there are some very plain study rooms. And it becomes clear that this is where the monks spent their time. If they were calling out to Mendel from those windows, there is a whole different part of the courtyard that they would have looked out onto. It makes much more sense for that to be where Mendel's garden really was.
As Mendel worked in the monastery, his priestly duties were limited because he became very upset and ill when he visited sick patients at a nearby hospital to offer them religious consolation. Abbot Knapp relieved him of that duty and others and encouraged his study of classical subjects and natural science.
I like to think of Mendel as kind of a situational monk. I don't think he joined with the priests because he had a calling. I think that he couldn't figure out any other way to get an education. His calling was really for knowledge. And when he was 21 years old and had tried every other method, he realized that what he needed to do was to join a monastery and they would educate him.
When Mendel arrived, a young priest, Matust Klotzel, was in charge of the garden, and they became friends. Klotzel became known for promoting Czech nationalist ideas and the teaching of the Czech language in the schools. The authorities and church leaders accused him of being a free thinker.
Therefore, he was dismissed from his post of professor of philosophy in Brno. There aroused student riots in support of Klotzel, and I would say that Klotzel had to disappear for some time from the monastery. Klotzel emigrated from the monastery, which he planned a long time before, came to the United States.
Klotzel left Moravia for America and settled in Belle Plaine, Iowa. He would become a philosophy teacher and leader in the Moravian Church and was later honored with this monument in Chicago. There is also a monument to Klotzel on the monastery grounds in Brno, originally facing the monastery.
Klotzel has been no more occupying his original place. His monument has been shifted, and now he's facing, of course, unappropriately, the wall of the brewery.
Soon after Klotzel's departure, Mendel took over the monastery garden, and in 1847, after 3 years of study, he was ordained in the Church of St. Michael the Archangel in Brno. What gave Mendel the chance that he wanted was a request made by the school in nearby Genomo for someone to teach classics and mathematics in the 7th grade. Abbot Knapp recommended Mendel, and he took up the position in October 1849, although he had not been formally approved.
In order to get his certification, he had to pass an oral exam. He developed, or maybe always had, a terrible case of test anxiety. He was a very fragile person emotionally. Even as he was growing up, if things didn't go his way, he took to his bed. And when he was a priest at the beginning, when he had to go cater to the sick and dying, he got so upset that he had to go to bed himself. So life was hard for him, and tests were especially hard for him.
Most candidates for the test had formal university education, but Mendel had studied independently while teaching 20 hours a week, overseeing his students and preparing lessons. To give him another chance, Abbot Knapp sent Mendel to the University of Vienna in 1851 to study natural history. It was the beginning of 2 years of enormous excitement and progress.
Mendel was in Vienna as a student at the University of Vienna because he needed a sort of degree, the so-called Lehramtsprüfung, just in order to be allowed to work as a teacher or gymnasium professor in Brno.
This turned out to be a wonderful part of his intellectual flowering. When he went there, he intended to be a physics student, and he studied actually with Doppler of the Doppler effect, and with a mathematics professor named von Ebbinghausen, who had developed this theory called the combination theory, the idea that any group of objects, man-made or natural, the relationship among them can be expressed in some sort of a mathematical expression, some sort of a combination. These kind of ways of looking at the world really informed Mendel's experimentation when he got back to the monastery, and really helped him figure out a way to look at his P's and his results in a whole different way, in a mathematical way, instead of just an impressionistic way.
Mendel had limited funds, so he was fortunate to find quarters near St. Elizabeth's Hospital in a building supervised by the nuns. At the university, Mendel came into contact with some of the leading scientists of the time, including Carl Nägeli, a renowned plant expert, and with whom Mendel later corresponded for many years.
Gregor Mendel studied a number of subjects here at the University of Vienna. One was physics with Doppler, for instance. Another was botany with Unger, and many other subjects such as mathematics, astronomy.
What Mendel learned from these men would shape his future. The mathematical analysis of natural events, the statistical principles of meteorology, the study of plants from a historical perspective, and the development of hybrids.
He returned to Brno in 1853 to continue his high school teaching, even though he still hadn't passed the required examination. On his second attempt, he had a nervous collapse and became too ill to go on. While he continued teaching, Mendel began a series of experiments in plant breeding that were aimed at answering one of the most important questions in biology: what is inherited and how? The answers that Mendel obtained from his plants became the foundation of the new science of genetics. It had long been assumed that plant reproduction just happened. Mendel didn't accept this answer, but pursued an idea introduced by Carolus Linnaeus: plants have sex. When the subject came up in his classes, Mendel described it in some detail, accompanied by classroom giggling. "Don't be silly," Mendel would say. "These are natural things."
One of the few trips abroad that Mendel took was to the London exhibition in 1862. He was part of a delegation from the town of Brno who had put together an exhibit on crystallography. It's interesting to think of Mendel having really studied crystallography right around this time when he was also growing his peas and getting ready for his description of inheritance, because crystals, sort of like genes, follow a particular pattern when they pass things on from one crystal to the next.
Mendel used peas in his study of plant reproduction. He chose the genus Pisum because it produces fertile hybrids and it is easy to grow. He studied peas to determine how traits were passed from one generation to the next. Others had observed these traits. Mendel was to draw extraordinary new conclusions. Mendel discovered three fundamental laws of genetics. First, each trait is determined by a specific element. Today we call them genes. One gene determines, for example, a person's hair color. Another determines eye color. Second, each characteristic or gene is inherited separately, without affecting the others. For example, hair color is inherited separately from eye color. Third, each inherited characteristic is determined by the intersection of two genes, one from each parent, and one is always dominant over the other. A dominant trait will be passed on from one parent. A recessive trait must be passed from both parents.
He did 6 other experiments on peas using different traits, again with remarkably similar results. He had laid the foundation for the modern science of genetics, defining the fundamental rules for dominant and recessive traits that apply to all plants and animals.
In 1865, the Society for the Study of Natural Sciences in Brno invited Mendel to present a lecture on his experiments. Mendel was not a well-known scientist, nor was he associated with a well-known institution.
Nobody said a word when he was finished. There were numbers everywhere because what Mendel did was counted up all these peas, looked at their different traits, and came up with ratios and mathematical equations that would express the relationships among the different traits. And it got more and more hectic as things went on, hectic in terms of just numbers everywhere. And I'm sure that people were barely paying attention. They also didn't understand the idea of applying physical and mathematical sciences to biology. That was something that had really never been done before.
Finally, Mendel formalized his findings into his famous paper, Experiments in Plant Hybridization. He took the paper to a printer and ordered 40 copies, sending them to prominent scientists and institutions, including Charles Darwin.
No one paid much attention. The paper was ignored or unread. One reason might be that botanists and zoologists of the day rarely studied mathematics and physics. They were unprepared for the advanced findings presented by Mendel. Mendel had published some papers in scientific journals, although he reported most of his observations on plants, other than peas, only in letters to Karl Nageli, a famous German scientist he had met in Vienna.
And he was an extremely good experimenter, fully concentrated, but he showed to be a bad manager in his de facto political post.
Altogether, Gregor Mendel spent 41 years in the monastery, and he had many accomplishments, though most of them were hidden from the world.
Mendel basically gave up on his gardening in the end of his life, but he took up a different hobby, beekeeping. And there was a bee house on the monastery grounds, and he used to spend a lot of time there, and actually tried to create an opportunity for the bees to mate in a way that would also show this 3-to-1 ratio of dominant to recessive traits. He also was always known as a kind of mischievous, puckish kind of fellow. And there's a story about one example of his sense of humor. He went up to the bee house with a younger monk when he was the abbot for many years. So here's big sort of fat Mendel, who's the esteemed abbot of the monastery, and this young man who's probably in his 20s. And the abbot brings him up to the bee house just around the time that spring is starting to come to Brno, probably in March. And so there's still a little bit of snow on the ground, but it's warming up a little bit. And he says to the young man, "Put your hat on the snow. Put your hat on the ground. I'm going to show you something." And so of course the guy has to. I mean, his abbot told him to. So there's the little black hat on the snow, and suddenly all the bees come out and defecate onto the hat and basically turn it yellow. Because Mendel knew, as this young man didn't know, that the bees hold in all of their excrement all winter to keep their hives clean. And then the first opportunity that they get where they think that there's some thawing going on, they let loose. And this black hat to them looked like some thawed, no more snow on the ground kind of area. I didn't think that was especially funny, but apparently Mendel did.
Mendel was one of the first to apply statistics to the study of meteorology, as he did in his plant studies. Using a full set of modern weather instruments, and for many years, he made daily recordings of temperature, wind speed and direction, barometric pressure, humidity, and rainfall. He made statistical analyses of 15 years of these observations, something that other scientists were only beginning to do. He also was very interested in astronomy, and kept records of sunspots, linking their numbers to the weather. Later, he helped arrange the publication of a weather forecast by telegraph and became a member of the National Sciences Society. Mendel was also a businessman, serving as vice president of a local bank and on the board of directors of another. He helped raise money to build a fire station and buy firefighting equipment, and he was made an honorary member of the fire brigade. As abbot of the monastery, Mendel led a productive life, but he was not well known outside of Brno. The world paid little attention to the studies that were to be the foundation of the new science of genetics. As time went on, he became more solitary, but always thinking of the garden. In a letter to his nephew in late 1883, he asked for grafts from the fruit trees in his parents' garden. But Mendel would not survive the winter. In the early morning of January 6, 1884, Gregor Mendel died of kidney failure. He was 61 years old. The local newspaper carried these words: "His death deprives the poor of a benefactor, and mankind a man of the noblest character, a warm friend, a promoter of science, and an exemplary priest." The funeral was held in the monastery church, attended by government officials, clergy, civic leaders, and many of the common people Mendel had always tried to help.
When he died, crowds of poor people accompanied him to the grave. And in his last years, he de facto lived in isolation, social isolation, because this was the result of his opposition towards the law taxating his monastery, or all monasteries, increasing taxation.
He was laid to rest in the monastery tomb in the cemetery, beside his friend Kryskovsky, whose music was played on the organ at the funeral by a promising young musician, Janáček, who later became an outstanding Czech composer. And so ended the life of a modest man who spent his life expanding knowledge. He quietly opened the door to the science of genetics without being noticed.
If you read Mendel's paper, it is a true classic, which, if presented today to a very rigorous committee, would be certainly accepted. It is a classic in this sense of applying mathematics and physics to the biologic science, even though he was not the first one.
In 1900, a Dutch biologist, Hugo de Vries, received a letter from a friend bringing Mendel's work to his attention. He was shocked to discover that the work done by Mendel 35 years before had led to the same conclusions he had reached. A second discoverer of Mendel's work was Karl Correns, a noted German botanist. He worked out the same 3-to-1 ratio of dominant to recessive as Mendel, using hybrids of corn and peas. Upon learning of Mendel's paper, he immediately published his own paper called Mendel's Law Concerning the Behavior or Progeny of Variable Hybrids. He said, "Mendel's paper is among the best ever written about hybrids." Erich Schermach of Vienna also rediscovered Mendel's work. He did breeding experiments with peas on what was later to become a world-famous experimental station, the Liechtenstein Estates. It was here that the potential of hybrids in agriculture could be used to benefit Moravia and the world.
Liechtenstein was a rich man, one of the richest men of the Austria-Hungarian Empire at the time, and he was owning many estates and grounds, and he was asked by Cermak and by some others to sponsor a sort of Mendelian research institute for plant breeding and for horticulture. And this he did in 1911, and he gave the foundation for an institute which is now called Mendeleum, and which is still active as a part of the University of Agriculture and Forestry in Brno in Czech Republic.
Schermach mentioned Mendel's findings in his publications and elaborated on them, but we may never know how much he discovered or how much he stole. Because of these three scientists' work, genetics became a legitimate new science at the beginning of the 20th century, and we know that Mendel was at least 30 years ahead of his time. The word genetics was discovered by a British botanist, William Bateson, based on the word Genesis.
There's a story about William Bateson that he was going to give a paper in London. He lived in Cambridge, where he was a zoology professor. And the story is that he got on the train to London, sat down and read a paper, and in reading the paper, which he said was Mendel's historic paper from 35 years earlier, he suddenly realized the brilliance of that paper, recognized that all the questions that they were answering in 1900 had been answered already, changed the paper he was going to deliver in London, and once he got there, introduced Mendel to the English-speaking world. I really like that story. I like that story so much that I opened my book with it. I had Bateson on his train to London reading this paper. And I was very disappointed to find out as I did my research that maybe it didn't happen exactly that way. And what I found very interesting about this story, besides the fact that it was a great story, is that Bateson himself created that story, and his wife perpetuated it. When the place that I first encountered it was in her memoirs of him after Bateson had died. So I found myself wondering why Bateson wanted everybody to think that that's how it happened. It's because, partly, this story makes him look like such a genius. I mean, here he was with this epiphany that nobody else had encountered, and all it took was 60 minutes, and he was able to read this paper, recognize its brilliance, and figure out how to describe it. So it made him seem like a much speedier thinker than he probably was. And it was a nice story that would add to this idea that Mendel was the founder of this new discipline.
Finally, by 1910, the world began to recognize Mendel's work. Hugo Iltis, who would later write the definitive Mendel biography, helped gather some of the world's leading scientists, including Bateson, in a place now called Mendel Square in Old Brno, to dedicate a monument to Mendel. Iltis escaped Czechoslovakia and the German invasion, becoming a professor in the United States. A scientific and political setback took place when the Communists occupied Czechoslovakia in 1948. Trofim Lysenko, a Soviet biologist, denied the validity of Mendel's findings in a major scientific conference in Moscow. Genetics was declared to be a false bourgeois science. He called it Mendelism. His idea was that the Soviet state would create a new biology in which characteristics of one generation would be passed to the next, regardless of Mendel's ideas.
The result of this movement was banishment of this scientist, of genetist in the Soviet Union.
Nevertheless, Lysenko's influence with the Soviet government was strong enough to establish a policy of condemning anyone who taught Mendelism to the Gulag or to death. The monastery was closed, the buildings converted to government use, and Mendel's greenhouse was demolished. In 1959, the communists removed Mendel's statue from the square named after him. It was eventually placed on the monastery grounds, overlooking the site of Mendel's garden. It was not until 1990 that the monks were allowed to return to the monastery where Mendel had spent most of his life. A Czech geneticist, Joseph Krznecki, had said that Lysenko's denial of the Mendelian laws was like denying the law of gravity. For this statement, he was imprisoned for 18 months. In spite of this hardship, he defended Mendel's work, and after the decline of communism, in 1965, he was given the job of establishing a Mendel museum in Brno, which remained open until 2001. The fate of this popular museum is now uncertain, as its collection awaits a new home. Mendel's influence on science continues. It is celebrated in the annual Science Award at Villanova University. In 2001, the Mendel Award was presented to internationally famous American surgeon Michael DeBakey.
Maybe he was a little bit hidden from the eyes because his way of thinking was very special. And look around, and the next 100 years will be Mendel's.
Szli na ścięgi, zaski w chleba.